Good morning, student. Let's start today's class. Today we will discuss about the type of modulation. Okay. In previous classes, we have already shown about what is the concept behind the modulation and the basic communication system. So now let us see what type of modulation we used in our communication. Okay. The type of modulation are of three types. Okay. One is amplitude modulation, second one is frequency modulation, third one is phase modulation. Okay. Now first of all, let us discuss about amplitude modulation. Okay. So when an amplitude of high frequency carrier wave is changed in accordance with, that means, you know, previously in previous class I told you that the modulation is the changing of characteristic of a high frequency signal, okay, in accordance with the or a high frequency signal which is carrier signal in accordance with the message signal. Okay, so here the characteristic changing of characteristics of carrier signal means the carrier or any signal have three characteristics. One is amplitude and one is frequency. Okay, next one is phase. Okay, so there are three characteristics in a signal. Okay, let's say this is a signal. Okay, then its signal have three characteristics. One is amplitude. Amplitude means this peak to peak, this much voltage. Okay, so this is called amplitude. Okay, and now another one is frequency. Frequency means in a time, in 1 second, how many wave. Let's say this is 1 second. Okay, in 1 second how many wave propagate through it. Okay, so one wave and second one wave. Okay, so this is called frequency. Okay, that means the number of wave passing in the time bound of 1 second. Okay, that is called frequency. Okay, now another one is phase. Okay, you see this is 0 degree phase. Okay, because it coming from origin. Okay, in the positive and the negative. Okay, but whenever and you see uh, this is sorry this is if we uh, this is okay, this is 90 degree phase shift. Okay, 90 degree phase shift. Okay, this is 0 degree phase shift. You compare it this and this. Okay, so this is the 90 degree phase shift. Okay, and if we draw this like this. Okay, so this is 180 degree phase shift. You see this is totally rotate the direction. This is this positive end coming to negative end, and this negative end coming to positive end in 180 degree phase shift. And in 90 degree phase shift, the wave in 0 degree phase shift, the wave starting from zero origin, zero to this much. But in 90 degree phase shift, the wave starting from this and going over. Okay, so this is 0 degree phase shift, this is 90 degree, this is 180 degree. Okay, so there are three characteristics. Based on that, the type of modulation is decided, that is uh, amplitude modulation, frequency modulation and phase modulation. Okay, now the first of all, amplitude modulation. Amplitude modulation, the name suggests that amplitude is modulated. That means the characteristic of amplitude is modulated. Here the characteristic of amplitude only changed with respect to the message signal. That means in amplitude modulation, let's say this is the carrier. Okay, you see this is the carrier, a high frequency signal. Frequency, the You see, high frequency means, let's say, this to this 1 second, okay? And if you consider this frequency, this is low frequency because the in 1 second only one wave is transmitted, but here in 1 second 4 to 5 or 10 waves transmitted. So this is the number of wave transmitted in one second is more, so frequency is more. So this is a high frequency carrier signal, okay? You see, 1 minute. You see, this is you see, this is the high frequency carrier signal, okay? And this is the audio signal we want to send, okay? So this is the after modulated signal, okay? After modulating this waveform we get, okay? And you see here, after modulating, this is the amplitude of the you see the carrier signal amplitude is this constant amplitude, okay? And the message signal amplitude is this. And you see the after modulation, the carrier amplitude frequency same, okay? And phase also same, okay? But the amplitude of the carrier signal, this amplitude of the carrier signal change accordance with the message signal. You see the amplitude like this, okay? Okay. And the other remaining characteristics like frequency, you see the frequency is like the carrier signal, okay? And the phase is like the message signal, okay? And also the carrier signal. So phase didn't change, okay? And frequency didn't change, only amplitude change, so that it is called M modulation, okay? Then you see the total. This is the total. You see, this is the message signal, okay? This is the message signal, and this much, you see the uh, the this much is the carrier amplitude, okay? And due to the negative, at the negative half cycle of the message signal, you see the curve is down, and the positive at the curve is up, okay? So you only remember that the amplitude of the um, amplitude of the carrier signal is changed accordance with the amplitude of the message signal in the amplitude modulation, okay? Now what is frequency modulation, okay? In frequency modulation, you know, the characteristic of frequency changing in accordance with the message signal, okay? Now let us see how. You see, this is the carrier signal, and this is the message signal, okay? So you see here, in the positive cycle the frequency is increasing, sorry, decreasing, little bit wider wave, okay? Then in the negative side of the carrier signal, the frequency of this is modulated signal, so frequency is modulated signal, frequency is increased, okay? That means squeezed wave or very consecutive wave, okay? Then similarly positive wider, negative higher, okay? So you see the frequency of this is the carrier, okay? This is the modulator. So here the frequency is constant, here frequency is varying with respect to the message signal, okay? So you see, in frequency modulation, the frequency of the carrier signal is um, varying with respect to the frequency of the message signal, okay? That is frequency modulation, okay? Now the next one is phase modulation. So you know, phase modulation, the characteristic of phase only changed. Here you see, other than frequency, okay, other than frequency, this is carrier signal, this is modulated signal. Other than frequency, the amplitude here, how that much, here also same amplitude, okay, and phase also same, okay. So only frequency component or periodic characteristic changed, okay. Now in phase modulation only phase characteristic is changed other than phase, frequency and amplitude didn't change, okay. So how, let's see how the phase modulation, okay. You see, phase modulation pattern that encode information as variation of the instantaneous phase of a carrier wave. Okay, phase modulation is a form of modulation that can be used for radio signal used by variety of radio communication. As will be seen later, phase modulation and the frequency modulation are closely kindred together, and it is often used in many transmitter, okay, and receiver used for the variety of the radio communication, okay. So modulated mobile radio communication, okay, and even more, even meridian mobile communication. Unlike frequency modulation, phase modulation is not widely used in the, you see, the phase in phase modulation, okay, this is the phase of carrier wave, okay, but this is the phase of, this is the phase of modulated wave. So you see the phase is shifted, okay, this is starting from this, here starting from opposite, so 180 phase shift is done. So the phase is uh, changed with respect to the input signal, okay, sorry, message signal, okay. So this is called phase shift modulation, okay. Now difference between AM and FM, similar thing, the FM is amplitude of the carrier remain constant with the modulation. In AM the amplitude carrier of the amplitude of the carrier changes with modulation, okay. Similar thing, that's all about your type of modulation. Thank you.